Good morning. My name is Sheikh Mohammad Muhid. I am studying my BTech in the stream of Electronics and Communication Engineering in Srinivasa Ramanjanam Institute of Technology. Today my topic is ionic polarization. Ionic polarization of the electron clouds around ionic compound. It occurs when an external electric field is applied, causing the positively charged nucleus of one ion to attract the electron cloud of an neighboring ion. This effect is scientification is understanding the electrical properties of ionic materials. Definition of ionic polarization. Ionic polarization occurs when the charge distributions of ionic distilled due to electronic source. They can result in dipole moment which affect the material overall electric behavior. It plays a crucial role of conductivity and dielectric properties of ionic substance. Mechanisms of ionic polarization. Ionic polarization is a primary caused by the interaction of electric field with ionic bonds. The electric field can pull the electron cloud away from nucleus of an ion, creating an dipole. The dipole is a process infused by the ionic radii and the charge of ions involved. Factors affected ionic polarization. The size of an ion has direct impact on polarization. Large ions tend to have more easily electrons clouds. The charge of an ion influence polarization. Higher charge generally lead to stronger polarization effects. The distance between ionic is an lattice structure affect how easily polarization can occur. Ionic versus covalent polarization. Ionic polarization is different from covalent polarization, which involves shared electron pairs being destroyed. In ionic compound, polarization is due to external electric field of the ionic bonds. Understanding the difference helps in predicting the behavior of material under electrical stress. Role in dielectric material. Ionic polarization is critical in determining an electronic dipole properties of materials. The extent of polarization affects how material respond to electrical field and their ability to store electrical energy. This principle is used in designing capacitor and other electric components. Polarization in crystalline solids. In crystalline solids, ionic polarization can be based on crystal structure and arrangements of ions. Different crystal lattice can lead to varying degrees of ionic polarization and different electrical properties. Understanding this variation is an essential for material science and engineering applications. Temperature effects on ionic polarization. Temperature change can impact ionic polarization by affecting mobility and lattice vibrations. Higher temperature often increase ionic mobility can lead to exchange polarization effect. At low temperature, ionic motion is restricted, decreasing polarization. Applications of ionic polarization. Ionic polarization is utilized in the development of sensors that respond to electric fields. It plays a role in design of solid electrolytes for batteries, improving energy storage capability. Additional understanding ionic polarization helps in development of high performance dielectric material. Measurements of ionic polarization. Ionic polarization can using various experimental techniques such as dielectric. This measurement helps in understanding the frequency dependent behavior of ionic materials. The polarization effects provide into the material's microstructure and ionic mobility. Change and consideration. One challenge in studying ionic polarization is the interaction within ionic lattice. Continuous research is necessary to improve our understanding and applications of ionic polarization. Conclusion: ionic polarization is a visual phenomena affecting the electrical properties of ionic compound. It understanding various applications in materials and electronics. Ionic polarization will technical and material development in the future. Thank you.